Hey, what's up guys, my name is Cherno, welcome back to my game engine series. So last time we began upon a series of like little mini series towards achieving mouse picking, getting mouse picking to work, which is basically us clicking on the screen, being able to select objects. Check out the video up there where we go over setting up a new frame buffer API that would allow us to render to multiple render targets, which is very important for the way that we're going to be sorting out this mouse picking. And today we're going to be continuing on that journey by actually being able to output, today's episode is going to be kind of like an extension of what we learned about in the last episode, which is more or less how to define a better frame buffer API. And today we're going to be creating a new frame buffer format, which is going to be essentially an integer, which is going to prepare the way for us to actually be able to output our entity ID into a texture so that we can then kind of click on a pixel in that texture and read back the entity ID and thus select that entity. So that's kind of like the full picture of how this is all going to click together. So let's dive in and take a look at where we left off. I'm gonna have a nice, quick, efficient episode here today, hopefully. If we open up the pink cube that we had, you saw that last time essentially we were testing our multiple render targets by outputting a solid kind of reddish color into the second color attachment that we had, and then this is us just testing that API to be able to display that texture attachment instead of the normal one, which if we go back to, because we should really restore the normal one, I think. If we just get rid of this one here, or put a 0 there optionally, because it's a default parameter that's set to 0 anyway. Then we'll be able to see hopefully an actual pink cube. All right, cool. So from this now, how do we convert our frame buffer into basically, well, I don't know about converting our frame buffer into something else, but ultimately, to phrase this better, let me show you what it's going to look like in the shader, right? So at the moment, we tested this by just duplicating our initial kind of color output. We just created another one that was exactly the same. You can see this inside the frame buffer when we set it up. You can see we have two frame buffer texture format RGB A8s, right? But we don't want to output a vec4. What we want to really output here is an int. And we want it to actually remain an int. So what OpenGL will do is it will actually, well, you can read about this on the various kind of like documentation pages that talk about the various formats, but basically what RGBA8 will do is it'll convert it into a floating point value that's between 0.0 and 1.0. Now that's a big kind of no-no for us, because what we want to do is we want to basically the whole point of this is so that we can, for every pixel on our screen, we can output the entity ID that pixel belongs to, if that makes sense. So in other words, if we render like one face of that cube and that's entity ID 5, then I want to see a bunch of 5s in place of those pixel values, right? 5 is an integer value. 5 is not between 0.0 and 1.0, and even if it was, it needs to be an int, not a float. And furthermore, we definitely don't need 4 of those, right? We don't need like RGBA8, I was gonna say, but we don't need RGBA where we have 4 of those floats between 0 and 1. We just want one int. Now, we could use an unsigned int. I'm not going to, and I might change my mind on this later, but ultimately, I like the idea of -1 not being an entity, right? Int still gives us 2 billion entity IDs, which is more entities than I think we'll ever have on in our scene, right? And then also, -1 is a nice little easy to understand, easy to read value to have, that will basically define no entity. So nothing is under the mouse cursor if it's -1. 0 we can't use because ent defines 0 as an actual valid ID, and I want to directly use the entity IDs from ent. Now, of course, if I was really cool, and I mean, I am pretty cool, so I could do this, but what I could do is I could still use a uint, but then from ent, like when I actually read back the entity in my C++ API, I could add a little +1 to that. So that basically that shifts all of ent's IDs by 1 over to the right. So in other words, if 0, that kind of makes way for 0 to be like a an ID that's not valid. But then we have to remember that every time we retrieve the entity ID from our API in Hazel, which is going to be the ent ID, the entity library ID, it has to be, 0 is valid, so we have to shift everything every time. That's a bit annoying as well. So easy solution, just make it an int, a signed integer, and then we can have -1. Again, I may change my mind on this later, but for now, this is the way it's going to be. So how do we actually facilitate this? So that's going to be our kind of goal for today. I want this to be output correctly, and you know, let's set it to like the value 50 or something like that, right? That's ultimately what I want. How do I read that back? Well, as I mentioned, RGBA 8 is not going to fly here. We need something stronger. So we'll use something called red integer, and I'll explain what this is. So basically in OpenGL, and maybe it's worth me actually implementing it first and then kind of explaining it. But in OpenGL, you know, we have our kind of standard like, you know, RGBA, we have RGB, we have RG, and we have R. But R is called red. Red is still going to be kind of converted to a float and clamped between 0 and 1, so it's basically the same as RGBA 8, except it's just one channel. That's still not good enough. We want it to remain an integer, so we have to use this OpenGL format called red integer. And so I'm going to create a format inside Hazel called red integer as well, just to match that. And again, we can't call it R. We could do it. We could call it RI or red I or something. But you know, you know me. I like to be quite verbose in my explanations so that it's very clear to everyone what's going on. So I think red integer is pretty clear. So let's go back into Framebuffer texture format, and we'll call this red integer. I might, like, again, the order has absolutely zero influence like into how everything's going to work. Like, it doesn't matter basically what order you define these in. I like to probably, well, you can see that I'm grouping these based by like kind of types, but with these things, like, you're way more often to want to have an RGBA 8 than like a red integer. Red integer is a pretty rare format. Something like RGB would be quite common as well, but red integer not so much. So I kind of also like to kind of be wary of formats that may not be used as often, because you know, you want to look at this and be like, oh, I want this format, not necessarily some other ones, because we'll probably end up having quite a lot of formats in here. That's all. Okay, so now that we've added a format here, we need to obviously create it using OpenGL. So how do we do that? Well, into GL Framebuffer we go. Okay, so ultimately what I want to do is I need to change this attached color texture function a little bit, because at the moment you can see that we do take in a format, which is actually the internal format, right? I called it format because it's the only format we take in here. But then we have GLRGBA here as the kind of access format. OpenGL has two formats: internal format. Format one refers to how the data is stored. One's referred to how it's like accessed in red. You know, we need this to be GL red integer, and we need this to be like GL, I don't know, 32i or something like that. So basically we need to extend this API so that we now have a format, but we also have an internal format, right? An internal format is basically what format is. So we need to replace that here like that. I'm pretty sure this is, yep, the internal format. And then format is what goes here. Now this doesn't matter too much. We can still leave it as on standby. We don't need like int, GL int or anything here. So for now that will remain the same. And then over here, obviously we've got a little error because we're now no longer, you know, now we actually need another parameter. So RGBA 8 is the internal format, and then GL RGBA is our regular format. Okay, so that's done. So let's add another case here, RGBA 8, and we'll also have red integer now, where the internal format will be R32i. There's also UI for unsigned int, but R32i is for a signed integer. And then obviously this will be GL red integer. Okay, that's it. That's all we need to do. Super simple. Now we're attaching a texture that obviously has a very different format. And I believe that is like, that's it. That is honestly it. And so now if we go back to edit a layer, obviously we'll make sure that we are dealing with red integer, and we are. And then if I run this, the purpose of running this is not necessarily to see anything, because we won't, but I just want to see if we get any kind of, you know, OpenGL errors or assertions or anything like that. You know, for example, the frame buffer being incomplete, or, you know, just like a GL error because we, are using the wrong format or something. Okay, everything's good. We don't see anything here. We've got some other kind of, you know, Google Drive stuff leaking in here, and we'll deal with that later. To be honest, I'm not even sure what's going on there. But it's hijacking our console. But ultimately, yeah, no OpenGL errors, so everything is good. Okay, next step. is let's actually see something work, right? So let's actually see us retrieve that value 50 back from the frame buffer, because that's what we ultimately need to do. This is like the placeholder for our entity ID, right? 50 at the moment. So what we should see, and what I want to do right now, is basically make it so that when I put my mouse over the screen, over this viewport, I want to be able to read whatever pixel the mouse cursor is currently under. And what I should see is just by outputting 50, if I'm anywhere on this cube, I should get back the value 50. That's my goal right now, right? And then if I'm not, then I will, well, ideally I should get -1. But if you actually think about what this is a value that we haven't set. We have cleared, we have done a GL clear, but we've cleared it with like 0.1, 0.1, 0.1, and 1.0 on the alpha. So that they're all floating point values, so they're going to show up as like pretty large integers, I think. So we won't get our -1 just yet, and we'll talk about clearing a specific texture attachment next time. But the goal is just, when I'm over the cube, show me 50. That's what I want to see, right? And I should be able to obviously move the cube wherever I want. Should be able to resize the viewport however I want. And if I'm over the cube, I want to see 50. That's the goal for today. So let's make that happen. So two parts to this. First of all, we need to get the mouse cursor, and we need to actually get the mouse position within that frame buffer. And not only do we need to do that, but mouse cursor coordinates, the top left is pretty much always 0, 0. So this up here is 0, 0. Now, as we know with OpenGL and with OpenGL textures, 0, 0 is the bottom left. So we need to do a little flip on the y-axis of just the mouse cursor, right? So if it's up here, it really should be down here in the texture. That's easy though. We can just basically take the viewport height and subtract the mouse Y from that, and that will invert it. That'll give us our little flip. And then obviously though, we need to account for things like the viewport size changing, this changing, and also we probably don't even want to, check to see what is under the mouse cursor if we're like not even on the right panel. So only when we're inside the bounds of the viewport. So that's what we need to do. Now to set this up, and I did this before the stream, during the stream, before I started recording, just to not waste everyone's time working out the math for this. But ultimately, to do that, we need to set up a few things with our IMGUI situation. So when we actually draw stuff with the IMGUI viewport, right, which happens, I think, over here. Where do we begin the view? So we begin the dock space. Here it is, viewport, right? We need to basically find out how big the viewport size is and also account for things like the tab bar. So the first thing that I think we need to do here is calculate a viewport offset, because every panel inside IMGUI, which is like really a window as well, has a potential to have a tab bar, but it kind of maintains its own internal state about whether or not that's shown. So what we can do is we can actually get a viewport offset by checking to see what the current cursor position is. So the current cursor position is where IMGUI is now going to start drawing the next kind of thing that it needs to draw. So if the tab bar is expanded, this will be larger. The Y coordinate of this cursor will be larger because it'll be lower down than if it's not there. So basically this kind of, I'll leave a little comment that this it includes the tab bar, because that's really what we're what we're using it for. So once we've got that, the next thing that gets drawn is the actual image. So after we've drawn the image, we can check to see what the cursor position is again, but ultimately we can basically just ask it what the window, I don't know, I might just copy and paste this because I don't want to spend all day here, and I'll explain it. But then the next step is to get the window size, get the window position, add that viewport offset to that minimum bound, which is the window position, and then figure out what the max bound is by adding the window size to the minimum bound, right? So basically what we end up with is this like little viewport bounds. It's kind of an array of 2 values. I'll add it here, glm vec2 viewport bounds. Whoops. And what this is basically the minimum and the maximum of where the viewport is. So if I take a look at what these values are, bounds equals, we'll do that. Let's do this. So let's take a look at what these are. And this stuff has been in Hazel Dev for a while, so to be honest, I'm not even 100% sure how I came up with this stuff. But so these are our min bounds and these are our max bounds. I've just put them into like an array, but basically 1 is like the max bound and 0 is the min bound. So if we take a look at this to see if it's even working correctly, then you'll see what we're dealing with. So 656 and 123 and 1394 909 is the max bound, right? So what this is basically telling us that like within, and you can see that it actually moves across like monitors and stuff, which is pretty cool. And that's because IMGUI kind of maintains a global position. But basically what it's saying is where on Earth in the world is this viewport defined on our screens, right? And obviously we need to make sure that we use this data along with also the absolute kind of mouse cursor position. And that's exactly what we're going to do. So the next step is, and it doesn't matter where you do this. At the moment, we're just running tests, right? So ultimately, I'm going to do this over here, right after we update the scene. But I'm going to now get the mouse position from IMGUI, which again will give me like a get mouse position, which will give me a kind of absolute on-screen position, right? And then I'm going to, from this mx and my, which I think returns a float, right? This returns two, yeah, it's a vec2, so it's 2 floats. Well, actually, how is this even working? Okay, yeah, whatever. 2 floats. Float mx, float my. So I'm going to subtract the minimum viewport bounds from this, which is basically bringing that back to 0, right? So that's now making the top left 0, 0. If I subtract both of these from this. One's a GLM vector, one's a non-GLM vector. So that's why I'm having to do it separately. I'm not sure if it's even worth doing that. I guess so. And then we'll also calculate the viewport width and height. So the viewport width will be viewport bounds 1 actually, dot x minus. Yeah, you know what? Let's kind of do this instead. I don't know, I might regret this, but viewport size, and we'll just do viewport bounds 1 minus viewport bounds 0. I think the IMGUI vectors don't have operator overloading, but obviously GLM does, so we can just do that instead of having to do it individually. And if this was an actual, you know, we could also combine this. Oh, that's a little bug. We could also combine this into like a vec2 if we really wanted to. Okay, so now let's go ahead and get an actual mouse x integer. So this will be just int mx. So this is now the mouse, but it's been moved into like, it's been put into the right space now because we've subtracted the minimum bound. So we can basically get that coordinate. And now, like, let's just test this out. So I'll take this, we don't need this anymore. And I'll pop it here, and I'll just replace this with mouse X and mouse Y. Okay. So now, what you should see over here, right, is hopefully a value between where that already looks flipped for some reason, which is a bit weird because I don't think I flipped it. Oh well. Oh yeah, it's negative, isn't it? Yeah, that's super weird, isn't it? Okay, anyway, the x coordinate seems right. What happened with the y coordinate? Oh, that was a bug, yeah. I was gonna say that was weird, because yeah, our y coordinate was on 0, but it was going up. Okay, this is better. Yeah, there we go. So you can see the top left is 0, 0, round about 0, 0. If we go off, it's like negative and whatever. And then obviously this is our viewport width and height. So now, technically speaking, we should be able to easily see whether or not our mouse is within that viewport or not. And I can do that by just saying basically if mouse X is greater than 0, technically greater than or equal to 0, and mouse Y is greater than or equal to 0, and mouse X is less than viewport size.x. Oh, that's why I think I wanted to do that, just because, or maybe not, because these are floats, but we can custom to an int. And mouse Y is less than viewport size.y, right? Then we are within the bounds, right? So now we'll only print it if we're in there, and we should be able to see that in action, right? So this is 0, 0. Obviously, if we're outside, we don't care. And then that's great because you can see over here, we're only printing when we're inside. So we only care about that. And obviously, if we resize, you know, we should be able to, you know, that should all work. Hard to see when it's not here, but there you go. Okay, cool. So that seems to be working pretty well. Now, as I mentioned, we need to flip the mouse coordinate. Otherwise, well, it doesn't work. So to do that, what we can do is to my, we can just simply, as I mentioned earlier, grab the viewport size.y and subtract it from my. Well, subtract my from viewport size y. So we're just flipping it. And now you can see that basically all that's done is made the bottom left 0, 0, which is going to match our texture. So now finally, all we need to do is ask OpenGL to give us the pixels of that texture. Now, reading back pixels from a frame buffer, reading back pixels from the GPU back to the CPU, not the best thing in the world. It's totally fine for what we're going to use it for. You know, there are also pixel buffer objects and like asynchronous ways of dealing with this stuff. I don't want to get into the deep end because we don't need to at all. But ultimately, what I want to do is use a function called glReadPixels that will enable us to read back the pixels from that frame buffer attachment, from that texture ultimately, once we've rendered to it. We'll have to add a function into our frame buffer. So what I want to do is, maybe we'll put this get specification. I'll do this here, virtual int, which again, we might deal with this later. You know, the API, the exact API we can discuss at a later time, but ultimately we need to have an index of the attachment. So I'll call this attachment index, and then like an X and Y coordinate. So we'll copy this, we'll go to GL frame buffer, we'll pop this under resize, override, and then I'll implement this. So this needs to bind and unbind our frame buffer. We're going to assume that it was not bound before. This is a bit dodgy as well because maybe it's already bound, and if so, do we really want to unbind it? Maybe, maybe not. Like, it's a bit, you have to be careful with this stuff is my point. Because again, you wouldn't want to anyway, you get the point. In fact, I think what I want to do is just not bind and unbind and say that you have to do that yourself manually, because otherwise it's going to be really tragic. But ultimately what we want to do is called glReadBuffer, right? Which will just kind of select a buffer for reading, because it's not this frame buffer. This frame buffer is fine, but what I care about is a specific color attachment. So color attachment 0 plus attachment index. And what you could do as well is do a little core assert to make sure that attachment index is less than like the number of attachments we have, right? So attachment index can be 0 and 1 in this case, because we have 2 color attachments, so that checks out, of course. And then we can basically call glReadPixels with a whole bunch of stuff. So X and Y, obviously X and Y. We're only interested in reading a single pixel. Now in the future, when we do like multi-selection, we might want to read a whole region and then scan to see what colors are there and then select those colors, right? Select those entities. But for now, we'll just do 1, 1. Formats, we're going to use glReadInteger. As I mentioned, very hard-coded, very bad. You know, just this is, you know, work in progress. glint is the type of data we'll be reading back, and obviously we need to actually get the data back. So pixel data and then pixel data I will create up here, right? So we're reading into this little memory buffer, which is an integer, and then we'll just return it. Okay, so we need to make sure that we bind the frame buffer first. I think at this point, it's probably already bound, right? Because we have an unbind later. I assume it's bound. So if we want to be really sure, we can bind it again. But I think binding it might actually clear it. No, maybe not. No, it says the viewport doesn't clear it. Well, whatever, we'll see if it works. And then over here, what I'll do is I'll just do frame buffer, read pixel. Attachment index is 1, and then X and Y is mouse X and mouse Y. And that should be it. So that's our pixel data back. Check that out. Now, at the moment, we're doing it every frame as long as we're in the viewport, so it will have a little bit of a performance impact, maybe like 1 millisecond or so. But we, of course, could change this to make it so that it only happens when we actually click, because that's at which point we really want the selection. But I don't know, I don't think it's a big deal. All right, so there's our kind of weird random value, right? Make sure that my face cam's not in the way. There's our kind of weird random value, but then when I put my mouse over this, we see 50. Right, which is exactly what you would expect. And then we can obviously move this off to the side. This is fine. Oh, there it is, 50. We can rotate it. 50. Anywhere where we output a color at the moment, we output the value 50, right? So those pixels obviously end up being that. And then obviously if we're off to the side, it doesn't print anything at all. It doesn't even do the read back from the frame buffer, and then it only does it here. So basically, I hope you guys see where this is going. The next step, which I would like you guys who are following the series and actually want to learn from it to try and do on your own before the next episode next week, try and somehow make it so that the actual entity IDs that we have like inside here, right? This entity handle, which is really just a uint 32t, right? Cast that into like an int maybe. I mean, it should work anyway. Should be an implicit cast, but ultimately somehow get that entity ID into the shader so that you can output that per pixel instead of the hard-coded value 50, right? And then you will magically know exactly what entity you're hovering over. And then of course you could easily make it so that when you click, it actually selects that entity top. Okay? So try and do that on your own, and then next week, obviously, I will show you how I will do it. But that is all there is to it. Now we can see exactly what's under the mouse cursor, and that is more or less done for this stage. So I hope you guys enjoyed this video. If you did, please don't forget to hit the like button. You can also help support the series by going to patreon.com/thecherno. You'll get access to Hazel Dev, which is like, you know, I mean, I hope you all know what Hazel Dev is by now. I've been making a lot of devlogs lately. You can check them out on my channel as well. But ultimately, it's a much more advanced... It's like my version of Hazel that I've been kind of working off to create this series as well. So it's got like 3D and animation and PBR and physics. It's got 3D physics now, 2D physics. It's got C# scripting. It's got almost everything in it. That's like the big guns. So if you're interested in contributing and helping to support everything that I'm doing here on YouTube and on Twitch with the Game Engine series, then that's definitely the best place to help support me. And in turn, you'll get a pretty cool little engine that a bunch of us from the community, as well as me, primarily, of course, are working on. So thank you guys so much for your support. I will see you next time. Goodbye.